Hello, everyone. Welcome to another Coding and Philosophy podcast. I'm here with Tri.
My name is T, and I am here with Yuho.
Yes, Juho, who now has written down notes.
Mm-hmm.
Yeah, I don't use my electrical notes, even though I'm a coder. But yeah, I have things in analog. Is that the right word?
Analog.
Yeah. So, Tri.
Mm.
Something watch. I was thinking we would discuss today is all the weird little quirks
Weird little quirk
which JavaScript has.
Yes.
So yeah, one thing which well, and this is my opinion on. I also share my opinion on how JavaScript possibly should be changed. So, well, first thing is in JavaScript there's something called the primitive types.
The primitive type.
And the non-primitive types.
The non-primitive type.
So primitive types are the strings, the booleans, the integers, all that stuff. And the ones which the non-primitive types are then objects, right? Something you can call methods on.
Objects are non-primitive.
But you know, it gets complicated in my opinion because you also have non-primitive versions of the primitive types. So that means
non-primitive version of the primitive type.
Yeah. So it basically means that I can create a Boolean object.
A Boolean object using an instance, right? So perhaps there's a string object and you instantiate a string using that.
Yeah.
Using that object. So like new string, and you instantiate a new string.
Exactly.
And if you call type of on that variable, it will return you an object.
Yes, maybe.
Because you mentioned that they are non-primitive version of the primitive one.
Yeah, it will return an object.
Really?
So, but the interesting quirk here is if you have like something, a string, a primitive string, and you call a method on it like trim, you know, the trim method.
The trim method.
So it removes any white space. But, well, primitive types don't have methods. They aren't objects, right?
Primitive type. Wait a second. Primitive type, like string.
Yeah.
We can call the trim method onto string.
Yeah. So, but the way JavaScript handles it creates.
It converts under the hood.
Yeah, exactly.
It converts the string into a string object under the hood and call the method on it.
Mm-hmm.
For real.
Yeah, it's called boxing. So, and I think that makes a lot of things really complicated. So if I was put in charge of JavaScript, I would just make everything a non-primitive type. I would get rid of the primitive types completely.
But what's the purpose of the primitive type when they are boxing under the hood to call the method on?
Purpose of the primitive types when they're boxing.
Right. What's the purpose of the primitive type then?
Well, I mean, I don't have a good answer for that because.
So that's new knowledge to me. So the string got converted into a string object under the hood, which a method can be called upon from the prototype of that object.
Mm-hmm. Yeah.
Quirky.
Yeah, so
Quirky.
JavaScript is kind of weird at times. So yeah, that's an interesting quirk. But another one is something called how functions retain memory.
How function retains memory.
So let's say you have a function which returns a function, and you run that
return a function
creator.
you run that function creator, which returns the function.
Yeah, and let's say you assign, or like set some variables inside of the scope of the birth-giving function or the function creator, right?
Function creator, so the outermost function.
Yeah.
You declare a variable inside that outermost function, and then in the return statement, you return another function.
Exactly. So something weird which happens is that the function that is kind of returned retains or has access to those variables which the
Right. It's a concept that I know as closure. The innermost function has access to the variable of the more outer functions.
Yeah. So it's it's weird how it retains some of that memory, and I personally, again, if I was in charge of JavaScript, I would just simplify and get rid of that. Well, also I know that I don't know, so I've just never seen a point where I go, oh, this is a useful, thing to have. I haven't, encountered such a situation in the code that I've written. That's the thing. I haven't found a coding pattern which uses it, which would be useful.
So the function returning a function in the situation when at the main execution context, the innermost function still have access. It still had access to the outermost function.
Or it's variables.
It's the variable. Pardon me. But this is what I imagine in my head. Inside the function that you return, the innermost one, it may need access to the mother's variable to do some operation inside it, right? So this is what I understand. This is what I also imagine. The outermost function, it accepts an argument, it accepts a parameters, and then it passes down that parameters to the return function. Then in that case, the innermost function needs the access to the parameters or the argument to do operations inside it. So this is when the memory retention happens, right?
Yeah, that's. But why not just access those functions? Those variables in
the we called it. No, this is too complicated.
I just.
Yeah, because I rarely in my experiences I have to come across with a function returning a function. I have seen that in practicing exercises and example code, but me myself, I've never used it.
Yeah, I think I haven't written in my scope of coding experience that it's why make it so complicated in a way. Or I would just rather keep it simple and find a way to access those variables somehow else.
Actually, somewhere else. An example pops into my head when I was learning React. When you are binding an argument, when you are binding a function to an on-click event, it must be a function reference. It's not a function call per se, it's a function reference. So the on-click event, it points to a function. And another work around is a function returning a function. That's what I remember from the example. Allow me to share it with you later on.
Okay.
Perhaps seeing the actual code itself reveals more of the utility of function returning a function and the usage of having parameters or having an argument in the outermost one and then it passed down to the innermost.
Yeah, it's a really important concept to understand because it's used, right, in a lot of those libraries and whatnot. But I just personally, when I've been writing code, I haven't found a chance or just a reason to use that or utilize that function, memory retention. Yeah. And I always, like I said, it complicates things. And when you're writing code, I think you want to keep things as simple as possible for newcomers to come and understand the code. And that's I would say, a more advanced concept. So, I guess you could write some fancy function which uses function memory retention, but why? I don't know. But that's just, like I said, that's I know that I'm not the greatest coder, so I just haven't encountered my mind hasn't comprehended a situation where I need to use this now. Yeah. And the final thing which we could get into is this keyword.
This is it.
This is it.
This is it.
So how...
Yes, the moment I've been waiting for, my friend. This is it.
So it's kind of... this keyword is... I think it's complicated because a lot of other languages don't have it. A few do. And in JavaScript, it points to, it references something.
It refers to the object of interest in the execution context. That's what I understand.
Yeah, but which object it refers to?
Which object? What is this? Which object it refers to?
It depends a lot on where you call it from.
So I have seen it mainly on a function inside a function call, that it refers to not the function. Damn it. The function nested inside can be the execution context.
Where? The function nested inside.
Function where this nested inside.
Mm.
So the way I can see I'm using this is, allow me to remember, I access to a DOM element using a query selector, and then run an event listener on the DOM element, and this points to the DOM element.
Yeah, I know what you mean now. Yeah,
but the callback function must use with the function declaration, the normal function declaration. When you type in function function,
rather than the arrow functions.
Because when we use the arrow function, it points to
whatever is in the outermost scope,
which is main execution context. That's what I've been observed.
Yeah,
it points to the main observation context.
Well, it doesn't always. Like if you use it, if you have a function and inside of the function you have an arrow function, then it points to the
outermost one.
Yeah, but if you use this keyword within the global execution context, I think it points to the document, if I remember correctly, or the document object.
Window object. Yeah, the most outer one is the window one.
Yeah.
The window.
You're right. But it's just, it points to different objects based on where you call it. And
I don't know. Yeah, sometimes I confuse. What is this?
That's the thing. It confuses. It's confusing.
But I kind of get the hang of it, or to be exact, when I work with certain problems and I have figured out the behavior of these keywords, like when I query for a specific DOM element and then add event listener onto that DOM event, using the function declaration as a callback and then use to refer back to that DOM object. I kind of understand the behavior because I have been confused and figured that out. So in familiar situation, we take this for granted, that I know this is it.
Yeah. Yeah, and talking about this is it, I think it's time to say our goodbyes. And yeah, thank you for listening to another episode of Coding and Philosophy. This was fun.
It was
talking
fun.
more like specifically about code and the quirks.
Getting deep into the details.
Yeah. Okay, we'll see you guys in the next episode. And keep on philosophizing.
And coding.
Bye.
Gotta debug them.